Okay, so are you able to hear me or should I wait?
No, so start.
Start, sir.
Okay. So see, so you have seen the constraint motion concept. Here also we have seen that shaft can only rotate. It cannot slide because its sliding is prevented from the collar provided here. Okay. So its motion is completely constrained with the help of mechanical connections. This collar is a mechanical element, okay, which is preventing the other motion. Okay. Similarly, it is so designed in its shape mechanically so that only sliding is taking place. Rotating and it's sliding in other axis about other in other axis is not simply possible. Then let us see what is successfully and incompletely constrained motion. So next is your incompletely constrained motion. What is incompletely constrained motion? Opposite of the constrained motion. Constrained motion takes place in a definite direction. Incompletely constrained motion can take place in multiple directions, in more than one direction. Okay. So, for example, what is the example of incompletely constrained motion? You see this figure where my mouse is there, that a round hole is there and a shaft is inserted in that. Okay, so this shaft can rotate, it can turn in the hole, no doubt, as well as it can slide in the axial direction. It is not, its sliding is not prevented. So here two motions are possible. One is turning and the second one is sliding in x direction. Okay, so you can say that the motion of the shaft is not completely constrained. It is incompletely constrained. Okay, so if you want to make the use of this arrangement, you have to first constrain the motion of the shaft. Okay, otherwise you cannot just loosely use it in this form. Okay, next next is the successfully constrained motion. Okay, what is it? When the motion between the elements, okay, forming a pair is such that the constraint motion is not completed by itself. Okay, means motion is not constrained by the mechanical connection like the collar which you used in earlier case. Okay, so how the motion is constrained? By some other means or force. Okay, then the motion is said to be successfully constrained motion. For example, shaft in a foot step bearing. Okay, so see here, it is the example of the successfully constrained motion. It is a foot step bearing and there is a vertical shaft. Okay, now what is happening here? Okay, so this shaft is rotating like this. It is rotating, okay, in this bearing. Okay, and at the same time you say that shaft can also slide in the upward direction. Okay, it is possible that it can slide in the upward direction, but when you apply some load, if you keep some load constantly on the shaft, okay, so what will happen? the shaft will not move upward. Its upward movement will be restricted. Okay. Otherwise, if we suppose that load is not there, then the weight of the shaft itself will act downward and will always try to keep contact with the bearing. Okay. So here you have not provided any collar like thing to prevent the upward movement, but weight of the shaft itself is doing that work. So you can say that such a motion is the successfully constrained motion. Okay. Successfully constrained motion. Are you getting the difference between successfully and completely constrained motions? Okay. So here load does that work. Load. Some sort of load is there, though there is no any mechanical connection. Okay. So that is the main difference. So these are the three types of constrained motion. Completely constrained and successfully constrained motions are of our use. Incompletely constrained motion is not useful in mechanisms. Okay, next. Now we have seen what is kinematic pair. Okay, we know that in a kinematic pair, the motion is a constrained motion. Okay, now let us see what are the different classification, what is the different types of kinematic pairs. So to classify the kinematic pairs, okay, there are different criteria. So first of all, first criteria, okay, to classify the kinematic pairs is according to the type of relative motion between the elements. Okay, so the elements, two kinematic elements which are forming the kinematic pair is having which type of motion between them. Okay, on that basis this classification is there. So one is sliding pair. So now you can have a guess that what kind of motion is possible between two sliding component. Okay, so when the two elements of a pair are connected in such a way that one can only slide relative to the other, the pair is known as sliding pair. What are the example? Again, you see the piston and cylinder of an IC engine. In an IC engine, the piston can only slide in the cylinder. So cylinder is nothing but a part of the engine frame. Okay, so that cylinder and piston makes a sliding pair. Okay, then ram and its guides in shaper. So that tool in the shaper machine which cuts, okay, with the metal, okay, it only slides in a particular path that is called as its guide. So it makes a sliding pair. Next is your turning pair. So what will happen in turning pair? As what happens in sliding pair, that the two elements slide with respect to each other. In turning pair, the two elements of the kinematic pair will have turning motion or angular motion with respect to each other. Okay, their sliding will not happen. Only turning or angular motion will take place. Examples are crank and connecting rod. Okay, then you can say crank and your engine frame, because crank will rotate with respect to that. Then wheels turning on axle shaft of the automobile, wheels will turn. So they make a turning pair. Then comes the rolling pair. What is rolling pair? Rolling pair, in this, one element will roll, will roll, okay, over the another element. Okay, so that is called as rolling pair. What are the examples of rolling pair? Ball and roller bearings. In that, what happens that those balls and rollers, okay, they turn on the inner and outer race of the bearing surface. Okay, another example of rolling pair can be given like a wheel which is rolling on the road surface. Okay, the vehicle is moving, and the its wheels is are rolling on the ground surface, on the road surface. So here rolling pair will be forming between the wheel and road. Wheel and road surface is in contact, right? So wheel and road surface will make rolling pair, and wheel which is turning on axle will form a turning pair. Okay, then there is the screw pair. Okay, what is the screw pair? In this, these two elements are in contact for, okay, no doubt. So one element can turn about the other by screw threads. Okay, so it has screw threads in it, and one element will turn in the another is called as the screw pair. So example is that nut and bolt. Okay, nut and bolt. So you can see that the difference between screw pair and turning pair is what? That in turning pair, no displacement occurs, no linear displacement occurs. But in screw pair, the as the one element will turn inside the another, it will also advance in axial direction. Okay, that is the difference between turning pair and screw pair. Next is your spherical pair. So one element, in what happens in spherical pair, sphere, it is in spherical pair, one element, okay, which is generally of spherical shape. Okay, one will be solid and one will be spherical cavity. The another element will have the spherical cavity, and the one element will have the sphere, and that sphere will be fit in that spherical cavity. So this element turns or swivels about the other fixed element. So that other fixed element will have the cavity in that spherical cavity. What are the examples of spherical pairs? So you see the ball and socket joints in your body. For example, this shoulder joint. Okay. Then we have knee joint. These joints are called as ball and socket joint. They form the spherical pair. Then another example is a car mirror. Okay, so a car mirror, you can say you can tilt it, you can turn it about all three axes, x axis, y axis, and z axis. You can only turn about all these three axes. So you can say that the attachment of the car mirror makes it a spherical pair. Mirror is one element, and on which it is attached is the another element. Those are the examples of spherical pair. Okay, so this classification is based on that which kind of motion is you have permitted between the two kinematic pairs. Based on that, you will see the kinematic pairs are classified into these five categories: sliding, turning, rolling, screw, and spherical pair. Okay, next criteria to, okay, we have 5 minutes. Next criteria, okay, to classify the kinematic pairs is on the basis of type of contact between the elements. Okay, so you know that in kinematic pairs two elements are in contact, right? So what kind of contact is there? Okay, so on that basis the pairs are classified into first lower pair and the second higher pair. In lower pair, what happens when the two elements of a pair have a surface contact, right? Surface contact, whole surface, or okay, or some part of the surface of one element is in touch or in contact with the surface of another element. Okay, it forms, okay, and the surface of one element slides over the surface of the other. The pair formed is known as lower pair. Okay, when the motion between them will takes place, there will be surface contact, okay, between these two elements. What are the examples of lower pair? You will see that almost all the sliding pairs, turning pairs, and screw pairs form the lower pairs. Okay, sliding pair, you know that when piston is sliding in the cylinder, so piston's cylindrical surface is in contact with the, yeah, inside surface of the cylinder. Okay, there is surface contact between them. Then again, in case of turning pairs, there is some pin joint. Okay, and that on that pin cylindrical surface, the links will fit. So they will have the surface contact on there over there. Again, screw pair surface contact is there between the two surface. Next, higher pair. So accordingly, higher pair we can define. In lower pair, there is surface contact between two elements. In higher pair, there is line or point contact. Okay, at a very small area, these two elements have contact with each other. Okay, and through that small contact, they communicate with each other. Okay, so such a contact we will call as line or point contact. Okay, what is the example of this? So a pair of friction disc. Okay, friction disc, you know that they are used to transmit the motion from one shaft to another shaft. See, it is one friction disc. It doesn't have the tooth over its surface. It doesn't have the teeth over its surface. It is very plain, but its surface is lined up with friction material. So friction will take place, and when this disc will rotate, say when this disc, one disc will rotate, so another disc will also rotate like this with the help of contact. So when they will contact at some point, their contact will be at very small area. That contact we can say as a point or line contact. So two friction disc which is transmitting the motion from one shaft to another shaft. Okay, say they are mounted on the shaft, both of them. Okay, so that's why this friction disc will make the higher pair. Next example is what? Gears. Okay, gears. You know what happens in gears? That teeth of one gear will engage with the teeth of another gear. Okay, and this contact is at very small point, a small area. So you can say that gears form the higher pair. Then in case of belt and rope drives, okay, it is a higher pair. It comes under the higher pair. Ball and roller bearings, okay. In ball bearing there is a point contact. In roller bearing it is a line contact. Okay, and cam and follower are the examples of higher pair. what are the KAM and followers, I will show you where it is. Okay, so the example of KAM and follower. See, it is a mechanism, KAM and follower mechanism. So should we stop here, or okay, only this point I will explain, then you can uh, sign off. Okay. So what happens in KAM and follower? This KAM, this is the one element, one kinematic element, right? And it is mounted on the shaft. So when shaft will rotate, this KAM will also rotate like this. Okay, and by as this knife follower, it is another element. KAM and follower makes one kinematic pair. See, they are in contact with each other. Okay. So when this KAM will rotate, this knife edge follower will reciprocate like this. It is one mechanism. Okay. So here what happens? There is a contact between them is at very small area here, and in this case it is the line contact, line or point contact here. So they are communicating very at a very small area. So KAM and follower is an example of a higher pair. Okay. Then there is another criteria on the basis of which the kinematic pairs are classified as self closed and force closed pair. We will see that in next lecture. Okay. Any doubt if anybody have, otherwise you can sign off.
Thank you, sir.
Welcome.